Mitochondria are the life force inside us all. They are the power supply in all our cells, providing energy for them to survive, thrive, and make sweet music. Our body's organs, brain, heart, liver, are high maintenance and require a lot more energy to perform their functions. When someone has mitochondrial disease, their mitochondria have become run down, and the cell's power goes out. They stop performing and start to die. So the body's organs don't have enough energy to work. Mitochondrial disease can affect anyone. Recent research shows that about 1 in 200 babies in the UK are born with genetic changes that can cause it. Faulty mitochondria have been linked to a number of common diseases. Whilst some people do not show symptoms, others develop problems that are undiagnosed or misdiagnosed. There are still very few effective treatments and no cure. For children with the disease, it can be debilitating and their lives can be cut tragically short.
The first treatment is called maternal spindle transfer. It works like this.
You begin with the intending mother's egg and a healthy donor egg. Inside both eggs is a spindle of chromosomes, which is what fuses with the chromosomes of a sperm to eventually create the child's nuclear DNA.
In this technique, you remove the spindle from the donor egg and replace it with the spindle from the intending mother's egg. Now, when the egg is fertilized by a sperm, the embryo will have nuclear DNA made from the intending mother and father's genes as usual, but with healthy mitochondria from a donor, unaffected by mitochondrial disease.
The other treatment is called pronuclear transfer. Here you also begin with the intending mother's egg and a healthy donor egg, but you fertilise both eggs with sperm.
When the newly fertilised eggs have become embryos of just a few hours old, the chromosomes from both the egg and sperm will have formed a new parcel, called at this stage the pronucleus.
You then remove the pronucleus from the donor embryo and replace it with the pronucleus from the intending mother's embryo.
Now the reconstructed embryo can go on to develop as in the other technique, with nuclear DNA from both intending parents as usual, but with healthy mitochondria unaffected by disease.
Britain could become the first country in the world to permit babies to be born with 3 genetic parents by the end of next year. A landmark decision by the Department of Health opens the door to techniques which will save lives by screening out inherited defects through the use of donated DNA from a second donor mother. The method raises many questions of ethics, identity, and whether it would lead to other, more controversial genetic selection.
This is a slippery slope into genetically engineered babies, picking the right hair color, the right height, the right athleticism. If we can start to engineer our babies before they're born, this is eugenics stuff. We don't want to quite go down that road yet where we're manufacturing our babies to specific standards, and it doesn't seem like we're there. But this breakthrough scientific technology certainly opens the door for that to happen, which is why I understand the controversy and why some people might be against it.
I have to worry that we are going to march down a road using genetics toward designing our descendants. We are seeing families who are fertile go to the IVF clinic and say, oh, you know, I'm worried about breast cancer risk. I'm going to make embryos, test them, and sort them out. That already happens. If you went to any kindergarten, private school in the United States and saw how much money parents spend to try and get a perfect kid on tennis camps when they have the means to do it, or, you know, fancy language lessons. We're a society that values success. We're not anti-perfection.
There's already a huge number of conditions and characteristics that we can screen for, and that we find if embryos, for example, are carrying them, the embryos are discarded. And that, for a lot of people, I think, has a a kind of uncomfortable eugenic implication. So I think that would be the main focus of our concern, that this is another step down the road of having too much power to design the next generation rather than just accepting them unconditionally.
It's really frightening. There are many ethical concerns. What are the most critical of those?
Well, I think one glaring problem here is they don't even consider the people that have these genetic diseases. They're ignoring them in favor of creating new individuals, genetically engineered individuals, designed to certain specifications that they hope, and it's only a hope, that they hope will not have these diseases. So you're experimenting with human beings, you're manufacturing new individuals, and unfortunately the creators are not really held to any higher standards.
Looks like playing God to me, and that's frightening.
For potential mothers with mitochondrial DNA mutations, there are currently a number of options available. 1. They can choose not to have children.
2. They can adopt children.
3. They can use a donor egg from another woman.
4. They can become pregnant and at about 11 weeks be tested for mitochondrial mutations in the womb. This procedure is called prenatal diagnosis. If it shows that the baby is likely to be severely affected by mitochondrial disease, they can then choose to terminate the pregnancy.
5. They can opt for pre-implantation genetic diagnosis. This involves a couple undergoing IVF, and the resulting embryos can be tested at just a few hours old. Then, only the healthiest embryos with the lowest level of mutation are returned to the mother.
So he pioneered this work initially in monkeys and did it successfully. And then last year we moved it into the clinic and we were able to do it successfully with human eggs. So there have been no children born from this technique yet, but we're at the point where, proof of principle, we show that it's possible to do this.
And the monkeys that were born from this procedure, are they okay?
They're apparently healthy. It's just a handful of monkeys so far, and they're growing appropriately, and they've looked at the mitochondrial DNA in each of their tissues, and it all comes from the donor and not from the mother, quote unquote. So that's reassuring. However, monkeys are not people, and that's the catch-22. I mean, you don't want to do it in people until you're pretty comfortable that it's going to be safe, but the reality is that you really won't know until you actually do it in people.
Who said three's a crowd? So we're talking about using 3 different types of genetic material to make one child. There have been successful tests using monkeys in labs that have resulted in healthy offspring. But what if the mitochondrial DNA is incompatible with the DNA? The mitochondria and the nucleus, they have to talk. So what happens if these 2 different types, they just don't communicate right? Well, there have been tests using fireflies and beetles that have actually resulted in males that were infertile or had other fertility issues. This operation would change the lineage of DNA for generations to come for any females of this offspring. Is this the type of operation that can help move humans towards a future free of genetic defects and mutations? Or are we pushing the envelope on genetic reproduction just a little too far? Do we need to wait a little bit more before we go into human tests? I don't know, but what do you think?